492, we're going to write out so far we found for the area of a triangle. Your very first formula for area of a triangle was like 1/2 base times height, or base times height divided by 2. That's usually the first formula you're going to use if you're asked to find the area of a triangle. However, there's going to be some times that they give you no height. They always have to give you a base, because if they just give you 3 angles, we just made the triangle bigger or smaller. Obviously, you can't figure out the area either if you only have 3 angles. But if you have one side, we learned in the previous section, the sine law section, that you can replace the, here I'll write it with the letters that I think are on your formula sheet. Technically, this is for the SAS situation. You have a side angle side, then you can use this formula. 1/2, you use the 2 sides and the angle between them, AB sine C, right? Because if this is the angle and we call it C, then this would be A and this would be B, so you have opposite of A would be little a and opposite of B would be little b. So if you have the side angle side, we have this formula. And finally, then the only thing that we can't find the area for is when we have the side, side, side. And so I'm going to introduce you to a new formula for the side, 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 and it looks like this. And it's on your formula sheet as well. And S in this formula is called the semi-perimeter. If you added up all 3 sides, A plus B plus C, you would get the perimeter of a triangle. The semi-perimeter is just taking it and dividing it by 2. So if I took the triangle that we have here, 8, 9, 10, and I add that up, I get 18 plus 9, 27. 27 divided by 2, my semi-perimeter would be 13.5. And so the area of that triangle would be 13.5 times by 13.5 minus 8, 5.5. 13.5 minus 9, 4.5. 13.5 minus 10, 3.5. If you multiplied all those together and square rooted it, you would get the area of the triangle. Kind of a neat formula because it doesn't use any angles whatsoever. That's also on your formula sheet. And because of this formula, I once won a hypothetical milkshake. So the reason it's hypothetical is the following. I was in a university class, and the professor put up this formula and said, if anybody can prove why this is true by next class, I'll buy them a milkshake. So I got excited. I said, I like milkshakes. And I like math. This seems like a perfect kind of connection. So after class, I sat down and I thought about it, and I spent a couple hours working it out, and I figured it out. And the next class, I brought my proof, which is still right here on the side of the filing cabinet, for why this is true. And I was excited. I was like, okay, let's get a milkshake. This is going to be really good. And the professor said, here's $2, go buy yourself a milkshake. Which is like the worst. Like, if he had said, anybody prove this, I'll give them $2, I'm like, yeah, no, but a milkshake, I was like, so I was super disappointed thinking I'd get a milkshake with the professor, but instead, I just got a hypothetical milkshake.
Did you buy a milkshake with the $2?
No, I think I was bitter. Technically, at some point. But even, like, I know, I'm getting old. But even back then, can you buy a milkshake for $2? You couldn't buy a milkshake for $2 back then. Now what's a milkshake? It's the cheapest place you could get a milkshake.
Yeah, like $6.
$6 somewhere is the cheapest you could get. And hypothetical milkshake. So now we have 3 formulas for area of a triangle. These 2, you could use, like I think if I give you an area of a triangle quiz on your quiz tomorrow, you could use either of those 2. But on our next quiz, we could have all 3. Okay, let's go to example 3 now. And what makes trigonometry questions hard is when they give you real life situations that you have to draw the picture. Drawing the picture wrong most likely will get you the question. So it gets a little bit tricky. A retaining wall is leaning at an angle of 70 degrees to the horizontal. A rigid support is placed 5 meters from the base of the wall and will be attached to the wall 2.5 meters from its base. Determine the length of the support and the measure of the angle. So first of all, what can make these questions hard is if you don't know what they're talking about. Do you know what a retaining wall is? Okay. Retaining walls are walls that are built to hold something up. Often it's when ground is uneven, and they would build a wall, and this one's leaning, so I'm going to build this wall leaning. It's holding up dirt. We're going to have orange dirt. And then there's ground over here. So they want that dirt not to like erode and make a hill. They want flat areas. So they build a retaining wall. But sometimes with retaining walls, the dirt is heavy, and they probably built it straight up. But over time, the weight of the dirt pushes it, and they tell us here that the angle between the retaining wall and the horizontal, here's the horizontal line, is 70 degrees. So this could be a problem because the whole wall could fall over. So what they do is they make a support. Here's a support to hold it up. And they say that that support is attached to the ground 5 meters from the base of the wall. And this distance right here is 2.5 meters up from the base. When they first built this, they probably made it 90 degrees, and you could have used SOHCAHTOA. But over time, it's bent, it's fallen over, we can no longer use SOHCAHTOA. Can we use the sine law? No, because we don't have an angle on the opposite side, so we have to use the cosine law. And I want to solve for this x right here. So according to my cosine law, well, again, I write out the cosine law for finding a side. The only thing that really matters is not what the letters are, but the fact that this angle goes with its opposite side. So if I want to solve for x, I would have to use, the x would have to go here, and the 70 would have to go there. The other side does not matter. And again, we're going to go to our calculator, type this in all at once. So, did I skip question 2?
Yes.
Yes. Okay, we'll do question 2 after question 3. Are you okay with that? It's going to bother some of you, I know. There's help. There's help out there. Okay. X squared equals, and we'll type this all into our calculator all at once, so 5 squared plus 2.5 squared minus 5, and instead of brackets this time, I'm using just the multiplication sign. Oh, but I forgot something there. Minus 2 times 5 times 2.5 times cos of 70 degrees. And I get 22.699. And then when you square root, you think about the plus or minus, but it's not needed here. Square root of that time I'm using the answer button right beside the enter button. 4.764. So I reread the question so I don't lose my rounding. What do I want to round to? The nearest tenth, 4.8. What are my units? Meters, 4.8 meters. And it's also important that I reread the question because it doesn't just ask for that. It also asks for determine the length of the support to the nearest tenth of a meter and the measure of the angle between the support and the wall. So which angle do they want? Do they want the one down here or the one up there? The one up top. So you have to make sure you read it. It says between the support, my support was here, and the wall, my wall is here. So that is this angle. I'll label it in orange. I'm going to call it, since I don't know it, I'm going to call it theta. We've already used x, so we should not use x again. Okay. But now that we found x, x is equal to 4.8. If x is equal to 4.8, can we now use SOHCAHTOA? No. Can we now use the sine law? Yes, because now we have an angle and an opposite side. Oh, this is going to be interesting for reasons that you don't have to know. Okay? I think they made a mistake here because we're going to get into the ambiguous cosine law situation, which shouldn't ever come up, but sometimes does. You'll never be tested on this on a test or on an exam. But I'll show it to you because it comes up in this situation. So we're going to do sine law. I'll switch to orange here. I want to find theta, so I'll put that on top. Its opposite side is 5. And here I'll put 70 because now I know its opposite side is the 4.8, but I'm not going to write 4.8. I'm going to write 4.764 ... to show you that I'm not rounding early, because rounding early can sometimes cause problems. And so sine of theta is going to equal, if I multiply both sides by 5, and I'm going to type that into my calculator, my fraction button, 5 sine of 70 divided by, and I'm going to go second answer to steal that answer with all of its decimal places from before, push enter. Sine of theta is 0.986. Now, according to our CAS rule, do you see that this is either in quadrant 1 or quadrant 2? So we're going to need to, here's an angle in quadrant 2, here's an angle in quadrant 1. Both of those would have the same reference angle. So we're going to need to find a reference angle. How do we find a reference angle? By doing sine inverse of the positive, which is already positive. So my reference angle, I go to my calculator, and I go second sine inverse of this answer. My reference angle is 80.45. The question asked us to round to the nearest degree. So then my reference angle is 80 degrees. And my actual angle is 80 degrees, or it's 80 degrees in quadrant 1. What would it be in quadrant 2? 180 minus the 80, 100 degrees. Look at your triangle picture. Oops. Are both triangles possible? Yes. 80 and 100 both don't add up to more than 180. So technically, they're both possible. I'll never give you one like this. Or at least I'll try not to. The answer to this one is just the 80 degrees. And the way that you would find that out is you'd have to do sine law with the 2.5 and find out which one works. Does the 80 make the 2.5, or does the 100 make the 2.5? And the 100 doesn't work. But if you just do the smaller one, that's what the textbooks want. They don't want you to see the ambiguous case for cosine law. They want to, like, it's like one of those things where, like, oh no, it doesn't exist. Let's ignore it. Question.
For that question, instead of switching to the sine law to get the angle at the end, could you use the cos c equals a squared plus b squared minus c squared over 2ab?
You could, because now you have three sides. Yes. So you have options. But if we're going through our list of options, as always, SOHCAHTOA first, sine law second, at this point, we would probably want to use the sine.
Yeah.
But you do have all three sides, so you could use the cosine law with all three sides. And that's what we're going to do in example 2 right away right now. But first, I'm going to give you questions, circle question 6.